Let's see how we can develop a box plot with the ggplot package. This is the ggplot package general function, and as usual, it takes two arguments. One of them is data, the second one is aesthetics. In the data, I'm going to identify which data I'm going to use. In the aesthetics, I'm going to identify which columns from the identified data set should be used to be mapped to the geometry or the visual. As we know, every plus identifies a layer, and the layer for identifying a box plot should be identified here, which is geom box plot. Talking more specifically about the box plot, the aesthetics, for the basic box plot, the aesthetics can be just 1x, which should be numerical, and there is no y, so there is one single variable over here. And as you know, the box plot presents the distribution of the column, and I already talked about the geometry. Let's develop a simple box plot. I'm scrolling down. The first thing I'm going to do is I'm going to call the library. The library was ggplot2, and as you know, when I call a library, I can use the content of that library. The diamonds data set comes from the ggplot package, so after calling that package, I can use it. I'm going to write head diamonds. So usually when I want to explore, and if I want to develop a visualization, if I want to investigate the data, I usually use this command of head to just refresh my mind about the data set. I can see the variable names over here, but I feel I really don't need to have 6 different rows, and I feel it's a bit waste of space. What can I do is I'm going to put a comma here, and I'm going to identify how many rows I want to see here. Let's say I want to just see 2. That's good. Or maybe you want to change it to 1 or 3 or maybe 9. This is your choice, but I want to just see 2 of them. Okay. And I have to choose a variable to develop the box plot. I'm going to use the price variable. The general form for developing a visualization from the ggplot package, the general function is ggplot. As you know, it takes 2 arguments. One of them is data, the other one is aesthetics. Right. And after that, I have to identify the geom type. Right. The data set I want to work with, as you know, is diamonds. The aesthetics I want to map from the diamonds data set to the geometry is x equals to price. Price is an interesting variable in the business context. And the geometry type is geom box plot. Don't forget putting the brackets. Let's run the code. And this is the results. This is a box plot. I can see the outliers here. The minimum, first quartile, second quartile, third quartile, and the fourth quartile. First quartile means 20% of data or observations are less than that. And I see the variation for the 21% of data is very low. Take a look here, what's happening between the between the first quartile and the second quartile. The variation is increased if you compare the width of this from here to here. With this width, you can see the change in the variation. Again, from the second quartile to the third quartile, I have another 25% of the data, and variation increase. And again, from the third one to the other one, the variation is going to increase again. This is interesting. It looks like there's a less variation, for the cheaper diamonds, and as the diamonds are getting more expensive, we have more variation in the price. Let's scroll up and let's take a look to this piece of code. There is nothing wrong with this piece of code, but I don't like it, because if I add more variables that I'm going to add right now, it's going to make it very long. What I'm going to do is I'm going to put the geometry type, which is a layer, here, and I'm going to allocate a name to this guy. I'm going to call it P. So what is P? The P is the x-axis of the diamonds dataset. I'm going to call this guy P, and I'm going to add P, which is the x-axis from the diamonds dataset, box plot, and the box plot will be developed. Yep, the same thing is developed, but this piece of code is much more workable. Let me kind of separate this, the library, and head with the actual code, and we're gonna go to this second part, not a basic bar plot. Let's see how we can develop not a basic bar plot, a bit more complicated, box plot. For a more complicated box plot, I can include a second variable of y, but I should consider y should be categorical, and yeah, and I also can change the color of the outliers with this argument outlier color. I can also change, when I'm creating multiple box plots, I can give different colors to the to different box plots. I can also partition my my box plot to different boxes. Let's see how it works. The first step I want to conduct is adding a second variable. Let me put a comma here and y equals 2 to show the second variable. And what variable I have to choose? Let's work with, it should be categorical, obviously. Let's choose this guy, the cut. The cut. And so box plots would be presented for the cut. Let me run the code. And you see the change in the box plot. I have different cuts: ideal, premium, very good, good, and fair. And this is the box plot for different cuts. And there are some good information in this box plot. For example, I see the variation. For example, considering the premium, the variation is very high. And for example, I can see the maximum price for the fair is over here, and the maximum price of the premium comparing to fair is much higher. I can compare the median, and I can also compare, like, for example, let's say the distribution in the distribution of the first quartile. This is the first quartile for the fair, and I can see, considering the first quartile, the variation of the fair is a lot. These are good piece of information. Let's say I'm not really happy with the color of my outliers, and I want to change the outlier color. There's a function which we already talked about that, and that argument is the outlier colors. We change the color of the outliers. If I scroll up, you're gonna see it's over here, outlier color. And obviously, because it is related to the shape, it should be inside the geom box plot. This is the argument about the shape. Let's do that. What I'm gonna tell him is out layer dot color should be equal to, how about red? Let's run the code and see the result. Yeah. So maybe I wanna try to more clarify the outliers by red, or maybe I want to change it to blue. Let's see the result. Not bad. That's good. So I have different options, but I believe for the outlier, a red should be a better option. Okay. I also want to further clarify the different cuts by giving them different colors. For doing that, I'm gonna come to my code, and I can tell him the color should be changed based on different cuts on the code. This is good. So maybe it's easier for my eyes to read the data. I can see, for example, this is the ideal one type of, how shall I say, one color here. I believe this is good. You can also feel it by colors. When I'm using the color argument, I just give the borders a different color. However, I can feel the shape, feel inside the shape by using the feel argument. I'm not really a big fan of using feel when it comes to box plots, but we can obviously try it. Fill equals to cut, which means fill them by their cut. And I really don't like this. I really don't like this. So if you like it, you can use it, but I guess we are missing some information. For example, I don't know where is the median anymore, and I really don't like this. So I wanna delete that fill argument and just have them with their color.